Very welcome to the bending chemistry of FFCBMD. And today, in the previous class, we see that packing fraction is equals to the mass defect by mass number gune multiplied by 10 to the power 4. It has been found that the packing fraction is a fundamental property of a nucleus and is directly related to the availability of nuclear energy and stability. The negative packing fraction implies exceptional nuclear stability. On the other hand, a positive packing fraction and hence mass excess indicates that the nucleus is somewhat unstable. Now we will talk about the binding energy. The mass of an atom in general is not equal to the sum of the masses of its component proton, neutrons and electrons. If we could imagine a reaction in which free protons, neutrons and electrons combine to form an atom, we could find that for all nuclides except H, that is hydrogen, the mass of atom is slightly less than the mass of the component parts, and also that a tremendous amount of energy is released when the reaction occurs. The loss in mass is exactly equivalent to released energy. According to the Einstein equation, cap E equals to m into c square, that is energy equals to change in mass gune velocity of light square. The energy equivalent to the calculated loss of mass is called the binding energy of the atom or nucleus. For example, consider helium nucleus, that is He sub 2 sub 4. It contains 2 electrons, 2 protons and 2 neutrons. Now mass of 2 electrons equals to 2 into 0.000548 equals to 0.001097 mu, and mass of 2 protons equals to 2.0151600 mu, and mass of 2 neutrons equals to 2.0178600 mu. Hence total mass m equals to 4.03411 mu. Now A equals to the mass of H nucleus, which comes out to be 4.00390 AMU. So mass defect cap M minus cap A equals to 4.03411 minus 4.0039 equals to 0.03021 AMU. Hence energy released is calculated from Einstein equation E equals to mc square equals to 0.03021 into 10 to the power minus 3 kg into 3 into 10 to the power 8 meters per second ka whole square, which comes out to be 2.719 into 10 to the power 12 joules. Here m is represent mass defect equal to 0.03021 gram or 0.03021 into 10 to the power minus 3 kg. Now binding energy are generally quoted as energy, and it is measured in million electron volt or mega electron volt per nucleon. So E equal to 2.719 into 10 to the power 12 by divided by 9.6 into 10 to the power 10 into mega electron volt. So E equals to 28 mega electron volt approximately. But the helium nucleus contains 4 particles, 2 proton and 2 neutron. Thus the binding energy per nucleon is 28 by 4 mega electron volt equals to 7 mega electron volt. Binding energy of the nuclei of other nucleus can be calculated in a similar way. The greater the energy liberated in the formation of nuclide from nucleons, greater is its stability. Here 1 electron volt, 1 eV equals to 23.06 kilocalorie per mole, or equals to 23.06 into 10 to the power 3 calorie per mole. Similarly, 1 million electron volt or MeV, mega electron volt, 10 to the power 6 into 23.06 into 10 to the power 3 calorie per mole, equals to 96 into 10 to the power 9 joule per mole, or 9.6 into 10 to the power 10 joule per mole.